Hello there, Mr. Sutton here with the IM385 Part 1 homework solutions on disjoint and overlapping probability. For this one, we want to find the probability of showing a 1 or a 2 on a six-sided die. So these two events, these are disjoint, they're mutually exclusive. It can't be a 1 and a 2 at the same time. Since they're disjoint, we just have to add the two probabilities together without subtracting any kind of overlap. So probability of a 1 or a 2, well, probability of rolling a 1, we've got a total number of possibilities that is 6, and then 1 is just one of those 6 possibilities. And to that we add the probability of a 2, which is also going to be a 1 out of 6, and that adds up to 2 out of 6, which we can reduce to 1/3. For this one, we want the probability, given a bag of 4 red, 4 blue, and 3 yellow marbles, the probability of randomly picking a red or a blue marble. So we have an OR statement here, so we have to think about overlapping versus disjoint. Now, a marble can't be red or blue, at least not in this problem. They didn't say there were any mixed color marbles. So this is a disjoint situation, which means we just find the individual probabilities and add them together without having to subtract anything. So probability of a red or a blue, probability of a red marble, well, our total number of possibilities is, let's see, the number of marbles. We've got 4 plus 4 plus 3, that's 11 marbles in total. So the probability of just picking a red marble is going to be 4, because there's 4 red marbles, 4 out of 11. And the probability of just picking a blue marble is also going to be 4 out of 11. So let's add those together. And again, there's no overlap, so we don't have to subtract anything. So that just adds up to 8/11. For this situation, we have a basket with 6 apples and 5 peaches. 4 of the apples and 3 of the peaches are rotten. And then you randomly pick a piece of fruit. We want the probability that it's fresh or it is a peach. So is it possible for something to be fresh and a peach at the same time? Well, it is, because they said 3 of the peaches are rotten, and that's not all the peaches, so that implies that 2 of the peaches are fresh. So we're going to have to calculate the probability, since these are overlapping, since there's overlap between fresh and peach, we're going to have to calculate the probability of each one, add them together, and then subtract the probability of having both of those at the same time. So probability of fresh or a peach. Well, let's deal with fresh first. And this is a little bit tricky here, but they said that 4 of the apples were rotten. So that means 2 of the apples are fresh, because there were 6 apples total. 3 of the peaches were rotten, and there was 5 peaches, so 2 were fresh. So we had 2 fresh apples, 2 fresh peaches. That's 4 altogether that are fresh. And how many total fruits did we have? Well, 6 apples and 5 peaches gives us 11 total fruits. And we said just now that 4 of them were fresh. Now, how many of them are peaches? This is a little bit easier to figure out. They came flat out and told us 5 are peaches. So we're going to add those 5 peaches together. So we've got the fresh fruits plus the peaches, but now since some of the fresh fruits are also peaches, we have to subtract those. So how many peaches were fresh? We said, let's see, 3 peaches were rotten. So there was 2 fresh peaches then to give us 5 total. So we have to subtract 2 over 11. Those are the fresh peaches. So we've got, let's see, 4 plus 5 is 9, minus 2 is 7, all common denominators, so that makes this a little easier. So that comes out to 7 over 11. For this problem, we're rolling a 6-sided die, and we want the probability of getting an even number or a number less than 4. Since we've got an OR going on, we have to ask if these are overlapping or disjoint, mutually exclusive. Is it possible that the number we get is both even and less than 4? Well, it is. There's an even number less than 4. It's called the number 2. Since these are overlapping, that means we're going to have to subtract the overlap when we calculate this probability. All right, so let's deal with the probability of even and less than 4 individually. So probability of even or less than 4, even first here. So a die has 6 numbers overall. That's the total number of possibilities. And out of those, 3 of them are even. That's 2, 4, and 6. Now the probability of getting a number less than 4, Again, there's 6 total numbers, and 3 of them are less than 4. The numbers 1, 2, and 3. So we're going to add another 3/6 to that. But now we have to subtract the probability of getting a number that's both even and less than 4. Because we've got the evens, we've got the less than 4s, but there's some overlap in these categories. So there's only one number that is both even and less than 4. That's the number 2. So we're going to subtract 1 out of 6 then, because one of the 6 numbers meets both criteria. So we have 3 plus 3, which is 6, minus 1 gives us 5. So that's going to be 5/6 for the overall probability. On this one, we have a standard deck of playing cards. We want the probability that the card we pick is a king or a spade. Since we have an or, we should ask if we have overlapping or disjoint events happening here. Can a card be both a king and a spade at the same time? Well, yeah, sure. How about the king of spades, right? So since these are overlapping, that means we'll have to subtract the overlap after we add together the individual probabilities. So probability then of a king or a spade, let's come up with our total number of possibilities. It's a standard deck of playing cards, so there's 52 cards overall. So we're going to have something over 52 for the things that we're adding together. And now the probability of a king, well, how many kings are there in a deck of cards? There's 4 of them, 1 for each suit. So that's 4/52 for just getting a king. Now for spades, there are 13 of each suit in a deck, so that's 13/52 that we'll add in there. And we've got all the kings, we've got all the spades, but some of the kings are spades. We have overlap, so we have to subtract that. There's actually only one king that's a spade, the king of spades. So that's just 1 out of 52 that we have to subtract. So then we have 4 plus 13, which is 17. Minus 1 is 16, so that's 16/52. And we can reduce this by 4 to get 4/13. For this problem, we have a standard deck of cards in which we're drawing 1, and we want the probability of getting a black or a red card. So red cards and black cards, they can't be both at the same time. So if we're thinking about overlapping versus disjoint, these are very much disjoint, mutually exclusive. So that means we're just going to add the individual probabilities and we don't have to worry about subtracting any kind of overlap. So probability of red or black. What's our total sample space here? That's just the total number of possibilities is just the 52 cards in a standard deck. So we're going to have something over 52. And now let's do red first. How many red cards are in a deck of cards? 26. Half of the deck. So that's 26/52. Plus probability of getting a black card. Well, there's 26 of them as well. So we add another 26/52. And that adds up to 52/52, which is just 1. Which makes sense if there's only red and black cards in a deck and you're asking what are the chances that you draw a red or a black card and there's no other types of cards, then you've got a 100% chance of getting one of those types. For this one, we want the probability of drawing a jack or a club from a standard deck of cards. Since we're dealing with or, we have to see if these are overlapping or exclusive, mutually exclusive. So let's see, can you be a jack and a club at the same time? Well, yeah, the jack of clubs is both. So these have a little bit of overlap, and we're going to have to subtract that after we add the individual probabilities together. So adding those probabilities together, first off, what's our total number of possibilities? We've got a standard deck of cards, so there's 52 cards in there. So we're going to have something over 52 for each of these probabilities. And now for our first probability, the getting a jack, well, there's 4 jacks in a deck of cards, 1 for each suit, so that's 4/52. And for the clubs, there's 13 of each suit in a deck, including clubs, so that's 13/52 that we're adding. And in terms of the overlap, there's only one card that is both a jack and a club. It's the jack of clubs, so we can subtract 1/52. So we've got 4 plus 13, which is 17, minus 1 is 16/52, which we can reduce to 4/13. For this problem, let's say we're rolling 2 six-sided dice, and we want the probability that the sum of the 2 dice will be less than 7 or equal to 10. And they gave us this nice little diagram here with all the possible combinations of dice. So since we're doing an or kind of statement, we have to ask, is there overlap between these two criteria, or are they disjoint, mutually exclusive? Can your sum of your dice be less than 7 and also equal to 10 at the same time? Well, they can't. If they add up to 7, if they add up to something less than 7, then there's no way they can equal 10, because 10 is not less than 7. So these are definitely disjoint, mutually exclusive. And that's good news, because it means we just have to find the individual probabilities and just add them together. We don't have to worry about subtracting any kind of overlap. So let's find those individual probabilities. So we're doing less than 7 or exactly 10. Let's do the probability of less than 7 first. Now, talking about total possibilities, there's 36 of them that we see here, 6 by 6. So it's going to be something over 36. How many of these possibilities, how many of these combinations add up to less than 7? And it really helps if you just kind of look at the pattern here. So 1 plus 1 is 2. 2 plus 1 is 3. 1 plus 2 is 3. And then you'll see that everything in this diagonal here adds up to 4. Everything in the next diagonal adds up to 5. And everything in this diagonal going from 1 and 5 to 5 and 1, those all add up to 6. So those encompass all of our possibilities for things that add up to less than 7. If we keep going diagonally away from this upper corner, we're going to get higher and higher sums just by the way these are organized. So let's count these up. We've got 1 here. Let's see. So we got, let me just count horizontally. We got 1, 2, 3, 4, 5. And then we've got, let's see, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is the last one, 15. So there's 15 different combinations that are less than 7. Now let's talk about equal to 10. And again, using our little trick with the diagonals, let's just keep going until we get a 10. So 4 and 6 gives us a 10. So does 5 and 5, and 6 and 4. And those are the only combinations that give you a 10 in this diagonal here. So there's 3 of those that we're going to add to the 15 over 36. We're adding 3 over 36. Those are the combinations that equal 10. 15 plus 3 gives us 18 over 36, which we can conveniently reduce to 1/2.